Okay, today I'm going to talk to you about the periodic table of elements. So all of our elements that we have, both natural and synthetic, are located on the periodic table. And this is a copy of the periodic table of elements. So first, let's talk about how did we get here. So the original periodic table did not look like the periodic table that we have today. Notice that lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine are straight across on this one. Whereas if you look at the modern one, there's a big gap. So we've learned a lot in a few short years. The first thing we have is John Newlands. He was a British chemist, and in 1863, he came up with this, or he discovered this law of octaves. So he noticed that there was something magical about the number of 8, that the properties of elements seemed to be repeated in sets of 8. So he wasn't really sure exactly what that meant, but he did at least get us that far. Then along comes Dmitri Mendeleev, and he's actually coined with being the father of the modern periodic table. He was a Russian chemist. He worked for the Russian Weights and Measures, and he also worked on liquefaction of gases and a theory of solutions. So he had his hand in a couple of different things. He lived from 1834 to 1907, and he discovered a few more things about the periodic table. However, this is what his periodic table looked like. So it was not quite where we are today. Not quite where we are today. Then along comes Henry Moseley. In 1913, Henry Moseley rearranged the periodic table by atomic numbers. And remember, atomic number is the number of protons in the atom. And he noticed that the number of protons gave you specific properties, so that the number of protons was actually the key in identifying the atom. So when he did that, we numbered them 1, 2, 3, 4, and we end up with this big gap, if you will, here. And we notice that there's other elements. Then Glenn Seaborg was an American, and in 1940 he discovered plutonium. He discovered lots of other elements that were not in the original 8 of octaves. He reconfigured the periodic table and added the actinide and lanthanide series, and won the Nobel Prize in 1951. Now, these are not by any stretch of the imagination all the scientists that were involved in getting us to where we are with what we know about chemistry and the periodic table, but these are just a few of the big names that really had a lot to do with where we are now. So the modern periodic table starts with 1, 2, we're all the way to, it looks like 118 on this one. And it is broken down by properties and groups, okay? And so we're going to talk just a little bit about the periodic table and all the information that it can give us. So the first thing you're going to notice is that on this one we have green, yellow, and white. So what do those things mean? Well, it turns out that all of the green ones are metals. Okay, all the green ones are metals. So if you see this, you'll notice that we have a whole lot more metal on the periodic table than non-metals. Properties of metals include they're shiny, solid at room temperature, they're malleable, heat conductors, electric conductors, magnetic, and ductile. Now, ductile is one that a lot of us don't understand. That means it can be stretched into thin wires, which is really important because we use copper wire for electricity and so on. There's several other things that we use as well. Malleable means that it can be hammered into thin sheets. And it can be manipulated to form jewelry and things like that. So those are all properties of metals. These are all the metals on the periodic table. As I said, all the green ones are metals. The trend for metals is that as you move this way in the periodic table, so as you move left and down, things become more metallic. They have a stronger metallic properties. So if you look at things like aluminum, has much less of the metallic properties than something like cesium or barium. They are much more metallic than the ones on this side. Okay, and these are just more of the properties of metals. Now, the periodic table of elements has different groups as well. So this first group of metals, starting with lithium, sodium, potassium, rubidium, cesium, francium, are the alkali metals. These are the alkali metals. The alkali metals each have one valence electron. The entire column has one valence electron, and they're very reactive, so they bond very easily. The next group we have are the alkaline earth metals. These have two valence electrons. They are the second column, and remember, columns go up and down, guys. The beryllium, magnesium, cesium, strontium, barium, radium. These are all the alkaline earth metals, and this is some picture of what it actually looks like. Then in the middle, we have something that's called transition metals. Now, these metals are a little bit different. They don't follow the rules just like the alkali and the alkaline earth metals. They have 1, 2, 3 valence electrons. It just depends. And some of them can exist in different states. So on these, for our purposes, you will always see in here like a +1 or a +2 or a +3 so that you can see what the valence is for these atoms, because they don't always have the same number of valence electrons. These are kind of like the stepchildren. They're the transition metals, and they don't always follow the rules. Then we have a group of nonmetals. Now, nonmetals here are the ones that are in the yellow. The properties of the nonmetals are they're dull, gas or solid at room temperature, they're brittle, they're poor heat conductors, and they are insulators, okay? And you notice these are more like powder, whereas the metals were more like, bits of metal, okay? The first group of nonmetals that we want to talk about are the halogens. These start with fluorine, okay? And these include fluorine, chlorine, bromine, iodine. Okay, and these all have 7 valence electrons. So this is, you look at the dot structure for fluorine, it has 7 valence electrons. Okay, these are also pretty reactive, but they like to bond with things that have 1 valence electron, and we'll talk a little bit more about that as we move into bonding. Okay, another group of nonmetals is the noble gases. These include helium, neon, argon, krypton, xenon, radon. These actually are called noble gases or inert gases because they don't really bond. They have all the electrons they need. Helium shell is full at 2 and neon shell is full at 8. So they really don't like to bond with others. So they this term noble comes from the nobility, too good to play with others, or and that gives us the noble gases. And you notice this is a neon sign. So they give this fluorescent hue. When they're heated, they actually become like a plasma. And so they make a good sign. Very easy to see. All right, and so after that, we have the metalloids. The metalloids are right here in the middle. They are the white ones, and they actually have properties of both metals and nonmetals. So as you transition from the transition metals, from the metals on the left side of the periodic table, you have these few right here that are a little bit undecided. So they have properties of both metals and nonmetals, and they're considered the metalloids. As we talked about with Seaborg, he discovered the lanthanide series and the actinide series. And so these actually fit right here like an accordion, okay? And they come down here, lanthanide and actinide series. And these were discovered later, remember, with Dr. Seaborg, and I think it was 1940. Okay, now just to kind of review everything we just said, this is a picture of the periodic table again. 1 valence electron in the first column, 2 valence electrons in the third column. These will have to give you, because remember, they don't play by the rules, 3 electrons in the third column, and this column right here, which on some periodic tables may be listed as 13, but this column right here, the boron, 4 in this carbon group, 5 in this nitrogen group, 6 in this oxygen group, 7 in the halogens, right? And then 2 for helium and 8 for all the rest of this group right here, which are the noble gases. Okay, so that's super important. So when we're doing our dot structures, right, instead of having to do all the subtracting or draw out the Bohr model, we can actually just look at the column that they're in to see how many valence electrons they have. Now, periodic trends, as I said, as you move down to the left and down, you become more metallic. As you move left and down, you become larger. The atomic radius is bigger. As you move to the right and up, you become more non-metallic. You have more electron affinity, meaning holding onto the electrons a little bit tighter, less likely to share. So we're going to do a whole section on periodic trends, but just so you know, where you're located on the periodic table does give you specific properties and tell you a little bit about how that atom will behave. Okay, and that was what I was just talking about. Atomic radius, metallic character, non-metallic character, electron affinity, and ionization energy, which are things we'll talk about in about a week when we talk about the periodic trends.